Okay, so E.J. Wagenmakers from University of Amsterdam is professor at the methodology unit of the Department of Psychology. He's PI on the European Research Council grant Bayes or Bust, Sensible Hypothesis Tests for Social Science. In 2016, he received a Lima Rosenthal Prize for Open Social Science for his design and leadership of the graduate level course, Good Research Practices at the University of Amsterdam. And he's been an active participant in the debate over p-value thresholds.
I do want to keep this short because most of you will be familiar with the general topic. So, if you want more details, there's a blog that I'm doing, Bayesian Spectacles, and it has a number of entries on this particular problem, most of them written together with one of my students, Quinten Gronau. So I would direct you to that for more information. We have about 11 posts on this topic right now. So there's 2 points that I want to make. One is about how to intuit the strength of evidence. I feel that's really important when we're talking about evidence. And the second one is that p-values just below 0.05 are weak, give you weak evidence, not just occasionally or sometimes, but always under any plausible analysis. That's really important. And I will demonstrate this to you using the JASP program. I don't know whether JASP is installed on this computer, but I made screenshots. So this is the intuition for the strength of evidence that a Bayes factor provides. So here we go. We have a Bayes factor, for instance, of 3, which means that the observed data are 3 times more likely to have occurred under the alternative hypothesis than under the null hypothesis. So 3 to 1. Now, assuming that the alternative and the null are equally likely a priori, we can transform this to a probability, so a proportion. So a Bayes factor of 3 relates to a posterior probability of 75%. Okay, so now we have this probability, but 75%, is that strong evidence? Is that weak evidence? It's a very concrete number, but people might still not really intuit how strong that evidence is. So we can create a probability wheel to make it more clear how much that is, right? So there's 3/4 is covered by the blue balloons and 1/4 is covered by the yellow balloon. And in order to really understand how much evidence this is, you can imagine that the wizard we just saw attaches a spinner to the middle of that wheel, spins it, and what happens is that the spinner ends up pointing to the smaller area. How surprised are you? Well, in this particular case, you wouldn't be very surprised. Would be a little surprised, but you probably wouldn't be surprised enough to write an article about it in which you reject the null hypothesis. Nevertheless, when we analyze p-values that are just below 0.05, the level of evidence is almost always lower than the evidence that you see in this pizza plot. And that should be cause for great concern. Okay, so let me demonstrate this to you. I could have picked any example, but I just took one that I ran into recently. Oh yeah, and so you can do all of this really easily with a couple of mouse clicks in the free program JASP that we have been developing at the University of Amsterdam. It does classical analyses, frequentist analyses, but it also does Bayesian analyses. So this result that I'm going to discuss was published this year in The Lancet. Now, they do a number of studies in this article, and I'm going to focus on the last one, and I'll show you the data immediately. So it's a correlation. These are 13 patients with post-traumatic stress disorder. And what you see on the x-axis is perceived stress. And on the y-axis is the activity in the amygdala. The idea is that people with an amygdala that is more active report more stress. Right? But then when you look at the numbers more closely, you see, this is impossible to see for you guys probably at this distance, but I'll tell you, the correlation is 0.56, and the p-value is 0.0485. So just below 0.05. And at this point, alarm bells should start to go off. And this reminded me of Shaquille O'Neal, the big Aristotle, who speaks of barbecue chicken alert in these kinds of cases. So what does he mean when he says this? He means that something is really very easy. You don't have to run after the chicken to catch it first. You don't have to pluck the chicken or cook it. It's just there for the taking, and you could do this all day. And similarly, when I see p-values just below 0.05, I can go to JASP, I can do a Bayesian analysis, and it will always show that the evidence is weak at best. So that's what we can do here. So p-value 0.049, barbecue chicken alert. So this is a Bayesian analysis. Obviously, I don't have time to discuss everything that you see here, but the most important point for this very short presentation is that base factor that is about 2. Right? So yes, there is some evidence in favor of the alternative hypothesis, but it's not really compelling. You see that we present a little pizza plot there as well. So imagine the spinner and it pointing to the white area. How surprised are you? Not at all surprised. Now this is just one analysis. And in the Bayesian paradigm, we have prior distributions. You could choose all kinds of different prior distributions. In JASP, we have a button for this. You can click, and then you get an analysis that shows you base factors across a wide range of prior distributions. So I don't have time to go into the detail, but what you see here is that on the x-axis, every point there is a different prior distribution. And on the y-axis, you see the evidence. Right? And important here is that no matter how we choose this prior distribution, the evidence is never compelling. And in fact, you see that it's fairly constant no matter what you do with this prior distribution. Right? So I believe that instead of presenting a number, say p equals 0.049, reject the null hypothesis, where you make an all or none decision based on weak evidence, it would be much more careful, modest, and appropriate to, for instance, present results like these. Like these two pictures tell you much more about what's really going on. Now, so this is really what I wanted people to do. But we are in the real world, and so I don't expect everybody to suddenly download JASP and do all these Bayesian analyses. So as a method to prevent me from shouting barbecue chicken alert and doing this to every paper with a p-value just below 0.05, we, a group of 72 authors, proposed to lower the threshold for significance from 0.05 to 0.005, because that prevents me from doing this. P-values around 0.005 will give us base factors of about 20 to 1. And that's kind of the level of evidence that people often think a p-value provides, but doesn't. So be aware of all p-values just below 0.05. So you may wonder, what's the reason for this discrepancy? Well, in the base factor we saw, it compares how probable the data are under the null versus a specific alternative. And it's the weight of the two that determines the evidence. When you compute a p-value, you only look at one side of the coin. Only the null hypothesis is considered. And that is one of the reasons we find this discrepancy. So bold claims require strong evidence, and you should all install JASP because it's a user-friendly program that allows you to easily do a host of statistical analyses. And that's it. Thank you very much.
All right, so let me just introduce our next speaker, Daniel Lakens from Eindhoven University. He's assistant professor of psychology at Eindhoven University of Technology. His work focuses on how to design and interpret studies, applied metastatistics, and reward structures in science. He's one of the recipients of the 2017 Lima Rosenthal Award as a leader in education for his Improving Your Statistical Inferences online course.
Hi. So I think one of the things that the paper that AJ just mentioned does really well is make people think about where their alpha level and their level of evidence that they desire should be. And that's good, because this is something that people have been unhappy about, that people are unthinkingly applying some sort of rule for a long time. And people have brought up this issue again and again. And I'm a little bit surprised that now so many people are thinking about this, but that's excellent. So that's really nice about this paper. On the other hand, again, people have been criticizing this use of p-values for about 50 years. You might think, so what's new this time? And actually not so much. If you take a look at the main novel claim that's in this, this paper by these 72 authors, then I think it's this. I mean, the statistical argument has been known that are presented, but the main thing here is that actually the point that the authors make is that now there is a critical mass of researchers now endorsing this change. That's really what they say. They say, wow, statisticians have known that the relative weakness of using this. This was all known. But the thing is, there's now a critical mass. And I find this a very interesting thing. So what does that actually mean? What makes 72 researchers a critical mass? And it also makes me think what the other people, like myself, so what are we then? I'm not really sure. Now, this topic is not specifically new. I wrote a blog post about this, not to say that I, thought about this before, but this is sort of the reason why we wrote a paper about this, because I already wrote a blog post in 2014 why psychologists should ignore recommendations to use an alpha level of 0.0 or 0.001. Then it was 0.001 a couple of years later, and we're at 0.005. I think if we wait another 5 years, we'll meet somewhere in the middle and everybody's actually happy. But now we're discussing 0.05. Now, the point that AJ mentioned, I'm completely in agreement about. So these p-values are low evidential threshold if they're just below 0.05. Actually, this is an assignment from my MOOC that I teach, where I let people plot p-curves. This is one for a situation where you have very high power, and you can see that the bar on the right, that's p-values between 0.04 and 0.05, it's very low, and actually if you take a look, it's below the red line. There's a small red line there. It's almost not visible maybe, but this red line is what you would expect, the p-value distribution, if the null hypothesis is true. So in this case, if you have really high power, it's true that you can find a statistically significant result, but that's actually more likely if the null hypothesis is true than when the alternative hypothesis is true. This is exactly the same point. And I test my students about this, how they should interpret p-values under this circumstance. So it's not that this is a disagreement. And again, this point, the question is, what should we do about it? And people have been debating this and thinking about this for a long time as well. This is my favorite solution if you want to keep track of the evidence in p-values. It's not to set a uniform threshold. I don't like uniform thresholds. That's the whole problem that we're in. And I'd rather not have a new threshold, have a real solution. This is by Good, 1982, where he suggests that you correct the p-value based on the sample size that you have. So the bigger the sample size, the smaller the alpha level that you actually use as a critical value, which makes sense, right? This is a good approach. So I had blogged about why I think we shouldn't have a uniform new lower threshold. And then this paper came out, and a lot of people on social media said, Daniel, you're going to write a commentary about this, right? I'm like, I don't know. Is this an issue? And more people did this, and eventually we ended up with 88 people writing in a Google Doc about this. It was actually a lovely writing experience with 88 total strangers. We wrote a pretty nice commentary where we make 3 main points. So why do we think that this is not a good idea? So first I think, and I'll briefly I have one slide about all these points, but I think there's really not enough evidence that this new threshold will actually improve replicability enough. The second point is that the justification for the new threshold is not something that I'm particularly impressed about. And finally, there could be negative consequences of having this threshold. And if you want to implement a new policy, you should think carefully about possible negative side effects. So why is there not enough evidence that in practice it's going to improve replicability? Well, we don't have a lot of data of how replications work depending on their p-value. But there's this one project, I'm a co-author of this paper, one of the 266 or something, where we replicated the 100 studies in psychology. And the bar on the left, just below 50% replication rate, that is for p-value smaller than 0.005. So this is the new threshold, and then, well, this is the only sort of objective data point that we have. We would end up with a replication rate of about 47%. It's not very high, right? It's not even looking very good, but okay. The question is it better than the other p-values on the right? Yeah, it's a little bit of a mess, right? We don't have a lot of data. Is it better? Maybe a little bit. How much? We don't really know. So there's not a lot of evidence how much is going to help in practice. The second point, yeah, I mean, in the paper we make a small joke that if you actually test how much better it is, then the evidence itself is actually not according to the new threshold. The second point is, do we want to have an alpha level, which is basically your error rate, right? How often do you want to say that there's something when there's actually nothing? Do you want to have this based on the level of evidence? There are some people, and I would point you to this blog by Stephen Sen, who's one of my favorite statisticians, and the picture also comes from him. Stop deforming the p-value into a second-rate, second-class Bayesian probability. So we don't necessarily have to choose the error rate based on the level of evidence. You can do it. It's one possible justification, but you don't have to do it. And if you do it, you might want to think, why do I think a type 1 error is 40 times more problematic than a type 2 error, which we probably going to leave at 20% if we power our studies at 80%. So this feels unbalanced. A second justification in the paper is based on the false positive report probability, which requires that you have some assumption about the prior probability that we test hypotheses that are true. We also don't have a lot of data about this, very few data points. So it's very unclear, very sort of doubtful way to justify this threshold. And the third is, if we are going to change policies, what's going to be the consequence for this? And I think that this is not a question for statisticians. The first 2 points are things that statisticians can discuss. This third thing is something that psychologists and economists need to discuss. So what are the consequences of setting this lower threshold? What are the problems for example, well, if you want to set a lower threshold, you need more resources to reach this threshold. Sort of 70% higher or 88% more participants if you do a one-sided test. So if you've used up your resources, yeah, you don't have anything left. And we might think that nowadays more people are doing replication research, but if you need more resources for your novel research, are they also going to do these replication studies, or is there a negative effect on the number of replication studies people do? Another thing is, what are the consequences for difficult to reach populations? If you do research on people, it's not easy to find a lot of them. Well, you can still, of course, do the research. The proposal is just to redefine significance, so your study should still be publishable. But will this really be the case? Will it be as impressive as other types of studies? Will people move on to do more research online? We don't really know the consequences, so I think that's important to think about. We have a very modest proposal, and I think it's nice also because before I said, yeah, in 2014 I said just ignore these recommendations to lower alpha levels, but now we had to think, so what else should we do? And we have a very, very weird proposal. Basically justify what you're doing. Don't just do a mindless sort of default, but make an informed decision and justify it in your paper. And then we thought, we don't even know how to do this, to be honest. We're now struggling because we committed to this idea ourselves, and now we have no idea. But I guess it's useful because it points out that we have to figure out and help people to make these choices. Finally, I just wanted to highlight my personal disappointment. So this is not for all the other authors, maybe some agree. But my personal disappointment with this proposal is that if we have this very problematic situation, so we have people doing a lot of things wrong, right? They place too much weight on single p-values. They treat p-values as evidence, which is sort of doubtful. They p-hack, they selectively report. Then I don't think that we really have a replicability problem, but we have an education problem, right? People don't know how to do good research, and we can lower the threshold, but I have doubts whether their theoretical hypotheses are interesting enough and those kind of things. So is redefining statistical significance an actionable step that improves the replicability of science? maybe to some extent. We don't really know how far, but only if you have a slightly different definition of what improving is. I don't think it improves science, and maybe science itself, right? I mean, we really want people to do good research. And for that, we just need to educate people. I think that's more important than giving them a new threshold to follow. All right, thanks, and these are all the people on the paper. Thanks.
All right, so our third panelist is Sameen Vizier from UC Davis. She's Associate Professor of Psychology and Director of the Personality and Self-Knowledge Laboratory at UC Davis, co-founder and president of the Society for the Improvement of Psychological Science, SIPS, and senior editor of the journal Collabra Psychology. And she's also a recipient of the 2017 Leamer Rosenthal Award as a leader in education.
Hi, everybody. It feels a little bit like my Twitter feed came to life. So I'm going to talk a little bit about my reasons for co-signing the 0.005 proposal. And I want to start by talking about some things that I think that we all agree on, or many people agree on, despite whatever position they take on the 0.005 thing in particular. And one is that the status quo is not good. We don't like the status quo. We all, or many people involved in this debate, more generally, think that the status quo needs to change. I think we also, many agree that in an ideal world, researchers would think through all of their decisions, and they would not just take the time to think through it, but they would think through it well. They would be smart, and they would be well-trained, and they would also not be biased and not make self-interested decisions about their research practices. And they would make all that thought process and decision-making transparent. And in this ideal world, the researchers would have all these qualities, but also, and maybe even more implausibly, the editors and reviewers would be smart and wise and well-trained and never make mistakes and be morally good people who are not biased. So I would love to live in that world, and I think in that world, the Justify Your Alpha proposal would absolutely be the best way to go. And I haven't given up hope that we can live in that world, but we don't yet. And so for me, the alpha 0.05 solution is a solution for the meantime, until we get to that world where researchers and editors and reviewers are all very, very thoughtful and wise and unbiased. And as somebody who has done quite a bit of editing and reviewing, really the appeal to me of this proposal is what could we do tomorrow? So before pre-registration is widespread, before everybody is completely transparent, et cetera. And I feel that many of the alternative proposals, not just Justify Your Alpha, but the Gelman, Tackett, McShane et al. Proposal and others require other things. They require transparency, right? We need to be able to verify people's subjective decisions about alpha or other research practices. And until we have that, right, what can we do in the meantime? So the alpha of 0.005 proposal is admittedly an imperfect solution. It's not a solution to everything. In fact, I think it's giving up on some things in order to have something sooner, right? It's kind of the eating the marshmallow now solution. But I think the advantage is that it doesn't require waiting until transparency and pre-registration are more widespread. It's something we could do right away. We don't need to convince people to abandon null hypothesis significance testing or to abandon thresholds or necessarily even to pre-register, although we should be pushing for many of those things anyway. So in my view, it boils down to my decision of whether to contribute to the 0.005 paper or not boiled down to, do I think that changing alpha to 0.005 is better than keeping it at 0.05? And I feel like that's, to me, is pretty uncontroversial. That if we had to choose between those two worlds, I would choose the 0.005 world over the 0.05 world. And I think that's not an extreme claim. So now I'm going to anticipate some criticisms. So one, I haven't heard very much. I don't hear too many people talking about that. Daniel alluded to it a little bit, but the idea that type 2 error rates could go way up if we use 0.005. And I think there's a couple of responses to that. One is that the increase in sample size you would need for an alpha of 0.005 is not as much bigger as you might think. It's reducing the alpha by, it's 1/10 the alpha rate, but requires only about 70% bigger samples. Also, the other counter argument I would say to that is that if we're worried about the imbalance in type 1 to type 2 error rates, and we're assuming that type 2 error is 20%, I think that's not a correct assumption. And you might expect me to say type 2 error is way higher than 20% because power is lower than 80%. But actually, that's not what I think. I think type 2 error is way lower than 20% because we have p-hacking and harking and so on. I'm not worried about false negatives entering the literature and having these like huge consequences for people not following up on true effects because they're not entering the literature. If that changes, I think we need to worry more about the balance of type 1 and type 2 error. Another criticism is that hard and fast rules are bad, so why should we have another hard and fast rule? And I agree, and that's why I don't think the rule should be hard and fast. I think there should be some flexibility around it, just like I think there should be when we were back in the 0.05 world. Well, we're still in the 0.05 world, but in that world, I think we should allow people to make a case for why they're not using 0.05 as their alpha. And I think the same would be true if we adopt 0.005 as the threshold for statistical significance. We should definitely allow for people to make a case for using a different alpha. But I think it's useful to have a default, something that you don't need to convince people if you're going to use this. You only need to convince us if you're going to loosen it up a little bit. Another criticism is that you can still p-hack to 0.005. And I would say, yes, of course, you can p-hack to any value, but I think it's undeniably harder to p-hack to 0.005 than 0.05. I still haven't understood the argument, and I've read the Harry Crane paper, I've read other papers. I've not seen an argument for how it can't be harder to p-hack to 0.005 than to 0.05. And I think the question is how much harder, and I haven't seen any good simulations or empirical evidence about that. But I think it's undeniably harder. It's at least a little bit harder to p-hack to 0.005 than to 0.05. So, and why does that matter? Why does it matter that it's at least a little bit harder? So here's my analogy. It also has to do with pizzas. I didn't know EJ would talk about pizza. So I was thinking about this on the train down from Davis yesterday, and this is an analogy I came up with. So it's brand new, so help me out if it falls apart. So let's say p-hacking is like eating pizza when you really should be eating healthy food. And p-hacking is pretty tempting when the pizza is really easy to get to. So if there's a pizza place just down the block from me, it's going to be really tempting to go eat the pizza instead of the healthy food that's further away, that's harder to get to. And the healthy food in this example is not p-hacking, using good research practices, sticking to the rules of NHST if you're using NHST. So what we're proposing with 0.005 is just moving the pizza store a little bit further away. How much further away? I don't know. Maybe it's a lot further away. Maybe it's a lot harder to p-hack to 0.005. Maybe it's only a little further away. But there's some chance that by moving it further away, the healthy option will become more attractive than the unhealthy option. So the idea is if we can make p-hacking less attractive, right, then maybe not p-hacking will be an easier solution. It'll actually just, people will be like, okay, fine, I don't have the resources to p-hack to 0.005, or I don't have the patience or whatever. I might as well try it the right way. So that's kind of my hope about why it matters that it's harder to p-hack to 0.005 than 0.05. But it's true that the validity of that argument depends on how much harder. Another criticism, and in my view the most important and valid criticism of this proposal, is that anything that requires larger samples, that requires more effort in order to claim a discovery, will encourage people to use the cheapest methods even when those aren't the best methods. And that is absolutely true, and that is something that every proposal for reform that increases the standards of evidence is going to have to deal with. If we require more evidence and we don't counterbalance that with something else, we're going to be driving people to use the cheapest methods available. Sometimes that's fine, sometimes those are bad methods. Like, over-reliance on convenience samples or questionnaire measures or reaction time measures rather than more intensive measures. So this is a real issue that we need to take seriously. And what taking this issue seriously means to me is a couple of things. One is that a lot of this credibility and replicability movement has been focused on statistical validity, and we need to be paying a lot of attention to things like construct validity, external validity, internal validity. So this needs to be a push for increasing all kinds of validity, not just statistical validity. And if we do that, then we will take into account, did they use the most appropriate methods? Did they use the most appropriate population, et cetera? And if you go cheap on those in order to get more statistical validity, you will be dinged for that. That all of those things matter, and you can't sacrifice one for the other. The other thing I think that taking this issue seriously means is to develop ways, BITS and Society for Improvement of Psychological Science and the Center for Open Science and many other groups are in the business of developing tools to help researchers. And one of the kinds of tools we need to be developing are tools that will level the playing field to make it easier to use these good, strong methods with fewer resources. So instead of, if people are being driven to use cheap methods when they shouldn't be, then let's make it easier for them to use the right, most valid methods. And what does that mean? Well, one example that I think is great is a couple of projects that came out of the Society for the Improvement of Psychological Science, namely Study Swap, which is, I call it like an online dating platform for researchers, but not for dating, but for recruiting participants, gathering data. So basically you can post a study that you want others to run for you, or you can say, I have a few hundred participants this year. If you want me to add your study to my protocol, we can collect data for you. And so that makes it possible for people who don't have a lot of resources to collect data this way, or for people to collect more diverse samples than they otherwise could at their own institution, et cetera. Another similar project is the Psych Science Accelerator, which is, again, an opportunity for people from many different labs across the world to come together and help collect data collaboratively. So those kinds of projects, I think, are going to really help address this issue of driving people to use cheaper and maybe less valid methods if we require more evidence. Another criticism of the 0.005 proposal is that dichotomous thinking is bad. I'm way too cynical to think we'll ever get rid of threshold thinking. I also think, look, we can do both, right? We can accept that right now thresholds exist and that dichotomous thinking is there, and let's make it a little bit better, but also at the same time push for more nuance and more training and so on. So these aren't mutually exclusive. And the other answer I have to the argument that dichotomous thinking is bad is correct, so let's have 3 categories instead of 2. Right? So adding the 0.005 threshold and then calling things below that statistically significant, and then having a category for things between 0.005 and 0.05 and calling them suggestive. Now we have 3 categories, so it's a little bit better than 2 categories. In conclusion, I want to say that another thing, I wasn't surprised at the reaction to the 0.005 proposal, but I find one thing about it interesting, which is that in psychology, in response to the replicability crisis, many people said, oh, well, of course we always knew that single studies were not conclusive, we're not dumb, like of course we don't treat them as conclusive. But then we let people in the discussion section of their articles get away with making quite strong claims. And then we also let those findings find their way into the media and into public policy and so on. So if we all know that we shouldn't be drawing strong conclusions from weak evidence, then let's just walk the walk, right? If we all know that 0.04 is weak evidence and we shouldn't be rushing to conclusions, then let's actually say that you're not allowed to call it statistically significant unless it's more extreme than that. So in my mind, there's a way of painting this proposal as just formalizing something that we claim that we all believe, that we claim that we all practice, but we often see people not practicing in their discussion sections and in the media. So I think that the looser system of saying, oh, of course we all know 0.04 is weak evidence, don't worry, we don't need a rule. My reaction is I think we kind of do need a rule. I think we haven't been behaving ourselves when it comes to interpreting that weak evidence and being calibrated and cautious about drawing conclusions. Okay, that's all I have.
Great, thanks a lot. I think there's a lot of material there, a lot of interesting ideas. Let me just start off with one question, and I have some thoughts about it, but maybe it's just a way to start a conversation. Different fields have very different costs of data collection, and so in development economics, in my field, certain experiments are done at pretty large scale, village scale, across dozens or hundreds of villages. They're quite expensive. They're difficult to carry out, very expensive projects. What are your views, sort of all three of you, what are your views on the sort of role of customized p-values by field, or maybe the role for research communities, separate research communities facing different constraints? You know, collecting fMRI data is more expensive than collecting online samples. Development economics is, data collection is costlier than maybe labor economics. Who knows? What do you see about moving again beyond this is the threshold versus that is the threshold, and sort of discipline-specific conversations? So just wanted to throw that out there. And I think if you could use the mic, whoever wants to go, maybe you can all take a turn. But I think it's on. If not, do you know if that mic is on? If not, we can. There's a button on it.
This, yes.
All right.
Well, since I have the mic anyway, I can be really brief. So, yeah, I think this is a very good question, right? We should consider this. And one of the ways in which we propose people justify the alpha level is by using decision theory. So what is the cost of actually saying, well, we're saying there's something going on here when there's nothing, but also the opposite cost, given the possible outcomes and the investment that goes into data collection. So I think decision theory is not used a lot to make these choices, but I think there is some agreement that it's probably an optimal way if we figure out how to do it. And maybe this is a good move towards thinking about how to do this. And then that would sort of solve the issue, right?
Yeah, so I have a slightly different perspective. So suppose you do your work and it yields a 0.049, right? Now, it's true that perhaps data collection was very costly and it was very difficult to get the data you got, but that doesn't make the evidence suddenly stronger. The evidence is still the evidence, and you're fooling yourself when you're saying, well, yeah, it's 0.049, but it was so difficult to get the data, so now I can make really strong claims. No, you still have to be modest. I do think that we should move to a situation where you could actually still publish those kinds of data. So I'm a big fan of the registered reports, where there's outcome-independent publication. And perhaps that's actually an additional benefit of the 0.005 guideline, that it will bring people towards those kinds of setups more readily.
Yeah, I think there are two separate issues here. One is what should the threshold be for making a strong claim, and the other is what should the threshold be for publication, or saying that we should put the evidence out there rather than wait and collect more evidence. So for easy to collect data, there's no reason to publish something if it would be easy to collect more evidence and get to a conclusive set of results. But for hard to collect data, I think a case can be made for publishing it even if it doesn't meet a threshold to make a strong claim. So I think it's important to separate those two issues. 0.005, your alpha in our paper was a threshold for making a strong claim. Completely separate from what should the threshold be for saying this is worthy of publication versus no, go back and collect more data, come back when you have something conclusive.
That's right, yeah, and the sort of rise of, in certain social science fields, of meta-analysis, where folks are increasingly combining estimates across studies and seeing that as a normal part of research, which in economics till recently it wasn't, feeds into this. So to the extent that I and my own research team, it's too expensive to collect a study that's well-powered to the level I'd want for conclusive evidence, but I know in my field 3 or 4 studies will eventually come along, and we'll think of the collection of those studies as sort of the body of evidence. That may be part of the story. Do you want to add something to that? Yeah.
Yeah, just one thing. So sometimes we have to do something, right? People are not always interested in making a claim how strong something is. But if you were the first study and you figured something out, and based on your data, there seems to be something that we should be doing, even though we're uncertain. But there has to be a choice that has to be made, then sometimes you have to make a choice. So the discussion is a lot about how strong a claim you can make, but sometimes people do research and they have to do something. Yeah, ideally we wait until we have a lot of data, but sometimes that's a third thing. So it's not publication, it's making a statement. Sometimes you have to have an action, right? Yeah.
Great. Okay, I wanted to open it to the audience. I know there's actually some authors on either of these papers, as well as others with views on this in the room. Don, actually, do you want to start out, Don? We should run a mic back to you. Is there a mic?
I'll just yell.
Let me repeat it since there was no mic. And so Don's question was, we've talked about type 1 and type 2 errors. What are some of the costs of having a literature full of or with many type 1 errors? So I think that was you were pointing to Daniel, I guess, on that? Or to the whole panel? Okay.
Yeah, so I don't know because I didn't quantify it, but I know that some people would say that there's a lot of pretty mediocre research that just has these just significant levels. And I know some people who say, yeah, so what? Ignore it. There's a lot of crap out there. Don't worry about every crappy study that has, that p-hack their way to an effect. And yeah, maybe sometimes 30 people spend 5 years on this topic. Yeah, that's a waste. You have to quantify how big the waste is. And it depends a little bit on the kind of research that you do, how big the cost is of some people messing around in a field which is not going anywhere, versus the cost of missing out on a potentially useful strategy. And if you are a field that has really good ideas that could benefit people, then missing out on one of these ideas is maybe much more costly than having 30 people muck around. I don't know, but that's the decision, right? That's the choice.
So here's one potentially very real cost, which is, let's say you're a grad student and you're submitting to a journal, and the journal treats all p-values below 0.05 as equally strong evidence. And so some people can get away with making really amazing, mind-blowing, counterintuitive claims, but with p-values of 0.04. And then some students hold themselves to a higher standard and say, no, I'm not going to believe it until I can reliably get p-values below 0.01, say. But then I'm not going to be able to claim things that are as eye-catching and clickbaity and so on. And if the journal treats those all the same, it's not going to accept those less exciting but more robust papers, and it is going to accept the ones that are going to get more attention but are less robust. So I think it's a cost that drives out good research, because probably the good research is going to be less exciting. It's going to lower your impact factor if you measure it just by citation counts and so on. So I think there is a real cost to not distinguishing between stuff that is more robust and stuff that's less.
I mean, yeah, I mean, that's probably true. I don't know. I mean, I recently looked at the studies by Daryl BEM about precognition. There are 9. One is 0.001, one is 0.006. I think he could have gotten it to, and one is 0.009, which also sounds like it could have gone there. So then it would have been a 3-study paper about precognition. Yeah, I think people can still get it in. You know, it's a good point, but yeah.
Just a background for folks not in psychology, the Daryl BEM studies are studies of telepathy, sort of communication, precognition, being able to predict things, which are really some of the crisis in psychology, experimental psychology, came after these studies were published, because they were seen as prima facie absurd findings. I think that's fair to say. So, yeah.
Yeah, so I'd just like to add that whenever this proposal comes up, of course, people start to talk about type 1 and type 2 errors. But I find it, I completely agree with Sameen that I find it more intuitive to think in 3 categories instead of 2, namely one where you have weak evidence, where things are unclear, and one where the evidence supports the null hypothesis or supports the alternative hypothesis. You have to move to a Bayesian framework, of course, but so I don't like to think in terms of these type 1 and type 2 errors, specifically because the proposal isn't about how things will proceed on average across all these experiments that you could do, but it's specifically concerned with p-values in a very narrow range, namely the range from 0.05 to 0.005. What should we do with those p-values? And our proposal, actually, it's a very modest proposal. I thought it was written with extreme modesty, like, let's just call those suggestive, right, instead of significant. That was really the only proposal, and people got really upset about it, which was, yeah, a little surprising to me how strong a response that very small change in just one word, a little different. Yeah.
I think some of the reaction to it is actually not necessarily people getting upset with 0.005. It's just getting upset with a threshold. And so a lot of the criticisms, which I think are very valid, I think there's a lot, you know, I encourage you to go and read all those, the criticisms of 0.005, because they include many really good criticisms of 0.05, right? Many of the things they argue against 0.005 are just as valid arguments against 0.05.
To add to this, I agree. I mean, I did a small poll on social media about what people would do, because I was wondering, so there's been some discussion, and then I said, so what are you going to do? Justifier alpha, lower it to 0.005, abandon significance testing. And then someone else said, well, wait until there is consensus. Now, that's not going to be a solution because there are 3 alternative approaches, but what there is consensus about is indeed that the old way is not, so you cannot wait. You have to do something, right? I think that's a very important thing. The choice is not, let's wait until there's consensus, because that's not a good thing, so. Yeah.
So this is a very interesting session, but I have to confess that in my world, we don't have point null hypotheses. We have interval hypotheses. We think coefficients are so small you can treat them as if they were 0. And if you're treating your null hypothesis with your probability, your alpha probability, you're totally screwing up my world because I'm getting totally wrong error characteristics for that interval. So I don't look at p-values as a way of making decisions. I look at them as a way of summarizing the data evidence. I don't have a spike of mass at 0. I have a continuous distribution from our prior. And I'm thinking about the shape of the likelihood function. And a low p-value means the likelihood function is concentrated on one side of 0. P over 2 is an approximation of the posterior probability of the opposite sign. So I take that small p-value as a symptom of measurability, not translating into decisions. That might come later. I mean, you got to have a loss function. You have to be explicit about the prior before you jump into any decisions. But particularly if the decision is treating this thing as if it's so small that it can be rounded off to 0, that's totally different from 0 in terms of statistics of it. So I think that, I don't know about psychology, but in economics, we don't have any of these point null hypotheses. And then I thought I'd give you an example. You're trying to estimate the rate of return to education at Berkeley. And so I did a study and I got a p-value of only 0.3. And you tell me that's terrible, but nobody has ever come close. 0.4 is the best you could do. So I think accuracy is a relative thing. And the things that should be studied or should be published are the things that are most accurate compared to the historical record. Secondly, we could have estimated rate of return to education that is 1% with a standard error of 1% and have a t-value exactly the same level if the rate of return is 10% with a standard error of 10%. If it's that second case, I want my kids and grandkids to go to Berkeley. But a 1% mean with a standard error of 1% is not going to carry the day. I'm just telling you that before you start marketing p-values that are going to be used in each and every context, you got to recognize that the context has got to have an impact on actual decision making. And we're leading people in totally the wrong direction when you endorse any kind of a conventional p-value. And the good solution is the one I think that comes out of any Bayesian analysis, which is your p-value should be a decreasing function of sample size, like he has, but then you don't know what level it should be. That has to do with a complicated aspect of the prior. So it's hard to be a real Bayesian decision maker, but the message seems to me to be pretty accurate.
Thanks. Let's grab that. Thanks, Ed. Yeah, I think go ahead if you want to comment on that.
So I agree, of course, with most of this, and I've advocated Bayesian procedures myself. So I actually got a lot of flack from my friends saying, like, "What have you done? You're suddenly promoting a p-value. You've never liked p-values, and now you're suddenly." So again, I'm with Sameen when I feel we're faced with a choice between two evil worlds, but one is slightly less evil than the other one, right? And I also thought it was interesting how you gave the Bayesian interpretation of the p-value, like the one-sided p-value as the area of the posterior to the one side of 0, which is actually also in a blog post, one of the series that I mentioned. We go into that, and I would say the base factors here are also based on a comparison against a point null, right? But excuse me. No, an alternative with so it's a spike and slab setup basically. But I would say, so John Tukey was already a fan of the peri-null, where you don't have a spike for your null hypothesis, but a distribution that's tightly centered around that null. And you can show that if you do a Bayesian analysis, unless your sample size grows really big, you'll get very similar results. But I think it's based on the context. I think I can give you some examples from the field of psychology where you would actually agree that the point null is plausible.
So one thing that sort of concerns me about the lower threshold possibility is it seems that if publication decisions start to be contingent on that, then even if key hacking stays the same or sort of isn't made more dramatic to try to reach the lower threshold, do we not end up with a published literature where reported effect sizes are even more inflated with respect to the truth than they already are?
Yeah, so I think there's a concern that if the p-value threshold changes and publication decisions are contingent on meeting this threshold, the published estimates in the literature may even be more extreme than they currently are. So that's an interesting point. Yep.
Very quick, yeah. I mean, I agree. We make the same point in the paper. Of course, you can say it's not intended as a publication threshold, but yeah. So that's the same for 0.05. Was also not intended as a publication threshold. I think the more important thing is we don't want a literature with only p-values below 0.005. We want a literature that looks like the real world, and that is a p-value distribution. So I would say that a very nice recommendation by these 72 authors would not have been make sure that all the p-values are low, but write a letter to editors and say, dear editors, if at the end of the year I plot all the p-values from your critical hypothesis in your published journal, and it doesn't look like a normal p-value distribution, you didn't do your job, right? That would be good.
Yeah, I completely agree. And I think plot two ones, right? Plot the distribution for conclusions that claim to find an effect, and plot the one for conclusions that claim to find no effect, or conclude that there's no effect. And then they should look different. Do that for sure. Yeah, this is kind of my argument that we need to push on many different fronts. And one of the really important fronts is to tell journals that it's not ethical to make publication decisions on the basis of significance thresholds. And also that includes, many people use that argument to say we should publish marginally significant results and let people make claims off of that. I have mixed feelings about that, but certainly when there's strong evidence for no effect or an effect very close to zero, that should be published as well. So it kind of goes back to the three categories, right? Strong evidence for an effect, strong evidence for no effect, or inconclusive, and then make an argument for why we should publish it even though it's inconclusive.
Yeah, so I think it's a great point, and I also believe that publication bias is probably the more important problem. Right, we're talking about p-values now, but the p for publication bias is the bigger one. But I still, even though you may argue that in terms of a policy, once you implement it in a specific way that we didn't endorse, but if you implement it in a specific way, it may have negative consequences, and that could be true. But not changing it still makes me say barbecue chicken alert for every p-value just below 0.05, right? And I can't understand why people would be comfortable with me looking at those p-values and going like, oh, here's a Bayesian analysis, doesn't give strong evidence at all whatsoever, and look at the claims in the paper, they are very strong. It seems to me that then we need to change the policy, but we can't pretend that the evidence is stronger than it really is.
I'll add one more thing just so people don't think EJ and I agree on everything. I don't think publication bias is the bigger problem. I think p-hacking is the bigger problem. I don't think there's a ton of people with really strong evidence for the null that are dying to submit it, and journals are sending them away.
But why do people p-hack?
Yeah, because, well, I think they p-hack for two reasons. One is that that's what they have to do to publish, but also because they believe their research hypothesis. So I don't think there's a ton of people coming up with evidence that goes against their theory and wanting to publish it, and journals are sending them away. Maybe in the future when we have more pre-registration and everything, that will happen and journals will be the culpable ones, but right now I think p-hacking is a bigger problem than publication bias.
If I could just make one point or ask a question to follow up on this, and I think it relates to this discussion, which is maybe the right sort of p-value, the right sort of alpha to be considering is the alpha used when you power a study, not the realized alpha, to say that only studies that attain a certain p-value below 0.05 are published sort of generates all the problems that we've been discussing. To say that actually we want higher quality evidence, or funders will only fund work that's sort of powered to appropriately to meet a particular alpha threshold, or even if regardless of what my realized p-value is, I can say, look, here's a plausible effect size, and I'm powered to detect it at 80% with a very low alpha. Then regardless of what the realized outcome is, that's a strong design. And I think those are two separate issues. And again, I think you could advocate for one or the other, but advocating for being powered to a certain level feels like it doesn't run into the very good problem that was raised here. It's results blind, sort of gets us back to registered reports. And
you get this kind of question a lot, but it seems like you're trying to put a Band-Aid on a very big problem. And the problem is that the incentives for people to do bad faith research and publish articles that they know don't reflect kind of the best practices that they were taught in grad school, or maybe not taught in grad school. Those just don't exist. So if you think about who's successful in a lot of social science disciplines, a lot of those people are just really great storytellers. And they'll find a way to tell a story given any set of results, and they'll figure out how to frame it in the literature so that it looks significant. And I don't think that adding one more hurdle for them is going to affect them that much. It might affect everyone else. So how do you change kind of the status system so that you reward honest, good faith research that might be boring or have kind of marginal findings, or encourage research that's more cumulative so that there's a back and forth discourse with some kind of partial verification? I feel like right now you're trying to slow down the best athletes, and these people are going to, I think, keep succeeding at what they're doing.
So I think that one good solution is not to make this an individual sport, because then people are going to try to outrun other people. And that's why some of the things that Sameen mentioned, like the psyche accelerator, I like the previous word for it, like that was CERN for psychology. And I think that's great. You know, get 1,000 people together, determine what the important questions are, solve them, be author 740 on a paper about it. That would be a great way to overcome these problems, I think.
Yeah, I think also I'm not as sure as you are that many of these bad practices are done in bad faith. And to the extent that some people are doing them not in bad faith, then these changes will help. But I understand your cynicism, and even if it's a small proportion of people doing it in bad faith, they will continue to get ahead if they're willing to p-hack harder or and so on. And then I would go back to Daniel's suggestion of write letters to your editors. Tell them that if they don't change practices, if they don't allow for null results to be published, replications to be published, encourage pre-registration, encourage transparency, things like that, that's what contributes to this unequal playing field and to being able to get ahead with practices that are not ideal. So I think the burden is on the gatekeepers. They're the ones who need to change, and I don't want to put responsibility on people with less power, but I also think that often people with less power think they have no power, but actually I think you have more than you think. And societies and journals, and they care what their members think and what their members want to see in the journal. So I would use that voice.
Yeah, and I actually also don't think that most researchers act in bad faith in this context. I think they can easily fool themselves into thinking, look, I've passed this threshold. We all agreed this is the threshold. And now that my research has passed this threshold, it is now an established finding that should be immune from all criticism. And if you think of it that way, and whether we like it or not, this is sort of the way it goes. If we think of it this way, we're misleading ourselves. I don't know that it necessarily that there are bad intentions, but people don't like uncertainty, and so the kind of black and white thinking, it tailors exactly to how people want to think. That's I think also why it's so difficult to eradicate it.
Why don't we take one more question, Sean?
Thanks, and thanks for a great panel. This has been really interesting, and I think a conversation to continue. So a comment and then a more direct question. My comment is that I think part of the difficulty, at least for me, and happy to write this up to my own thickness, is I sometimes am hearing 4 arguments being combined as one, and I think taking them in turn would be helpful. So what's the problem? Is it p-hacking? Is it publication bias? Type 1 error rates, type 2 error rates, false discovery rates that we're trying to address? What is statistical significance? Actually defining it. So this threshold we talk about, is it for publication? Is it for submitting a journal article? Is it for accepting a journal article? Is it, I should believe this, I should act on this? I think all of those are being debated. Should we have such a threshold at all, regardless of what that is another debate point. And if we should, what should this threshold be? And so I think maybe in future Twitter battles, retorts taking those in turn would be really helpful for me as someone who's an author on neither of these, but deeply interested in the conversation. And then my more pointed question is for EJ, actually, but would be keen to get the responses, and it's more because of my naivete with Bayesian statistics, but it seems like your specific argument, or one of them for the p.005 threshold, is based off of a Bayes factor of 3 being an important threshold from your simulations. It seemed like that was a qualitative benchmark. So if you could, for my edification, justify or explain where that comes from. I mean, was that something decided like 0.05 in the past, and so we're using one arbitrary threshold to support a new one, or is there evidence behind it? And then secondly, of all the teams Shaq played for, why the Suns? Never seen that in a presentation as someone who grew up in LA.
Maybe this is a good chance for you guys to respond, but also some closing thoughts too, as we'll wrap up.
Yeah, so in order of importance, the picture from Shaq is there because I Googled for free pictures. So the good ones weren't free. Then right, the Bayes factor of 3. Now it is true when I discussed the number 3. You are completely right. Harold Jeffries, who really was the one who promoted and developed Bayes factors, came up with this list of thresholds that are just as arbitrary as 0.05 and 0.01. Nevertheless, the argument is not based on a Bayes factor of 3. The argument is based on the fact that a Bayes factor of 3 isn't very compelling. Right? That's what I tried to show with the pizza plot. And if you analyze p-values that are near 0.05, you will find Bayes factors near 3 and sometimes a little lower than that. So that indicates there's a problem. And the reason why we then proposed the 0.005 is because that actually corresponds to a Bayes factor of around 16 to 20. Right? And so that is actually much more compelling. So that was the reason. And with respect to those thresholds, I have mixed feelings about them, so that's why I also always like to present the pizza plot, because that gives you a continuous idea of what the evidence really is.
So yeah, just as sort of my two closing thoughts, I would say. The first is that there should be more than a p-value that's important to judge the evidence in a study, right? So there's statistical evidence, but just a single p-value, doesn't matter how low it is, should never be good enough to end up on the front page of the New York Times or whatever. That's the first thing. And the second is so there's a lot of agreement about some important things. I would say, just to add, that sometimes we can agree publication bias is, I think, the biggest problem indeed. Regardless of which approach you want to decide upon, I would say give this a try to justify the alpha level in your next study. Just give this a try. I think that's going to be a very interesting exercise for yourself, that you realize how strongly you just were guided by some threshold you never thought about, and the moment you're forced to think about this, I think that's a very educational thing, so that would just be my homework.
So I'm going to take the approach they take on Wait, Wait, Don't Tell Me, where at the end of the show they ask the panelists to predict what's going to happen next. And something you said, Ted, actually made me think of this, talking about meta-analysis. So what I think is going to happen next is people will show that across their 3 or 4 or 5 studies in their paper, they get below the 0.005 threshold. So even if their individual p-values are only suggestive or maybe even marginal, together, meta-analytically, they have strong evidence. And that's terrible, and we need to not go in that direction. As much as I think meta-analysis conceptually is the right way to think about accumulation of evidence, when we don't have safeguards in place to make sure each individual result is accurate and valid, then combining them together just amplifies any bias that's in the individual studies. So rather than computing a meta-analytic effect and p-value associated with it and celebrating if that meta-analytic p-value is very, very small, I would say look at your distribution of p-values. And if you don't
see a distribution that looks like it came from a non-null distribution, then it doesn't matter how small your meta-analytic p-value is. So if you have a 0.04, 0.03, 0.05, 0.06 combined together, you get a really small p-value. That doesn't matter because you wouldn't get those 4 p-values if you had a real effect, hardly ever. So you should be worried about why you got those 4 p-values, and you should not be satisfied that you got a meta-analytic effect with a small p-value. That's what I think is going to happen next. I think internal meta-analysis and even regular meta-analysis that finds overall strong evidence is going to make people feel better, and we should not drink that pill. That's a dangerous path to go down. My other concluding remark is if we're going to pick a basketball player to use in these discussions, it really ought to be Tim Duncan, the big fundamental, because he actually was a psych major and published a psych paper.
Wow. Okay. And maybe a future BITS network member. We're going to reach out to him. Great. That was a really thought-provoking session. I'm sure we'll have a lot to discuss in the coffee break for the next 15 minutes. And then at 3:30, we're going to come back for our panel on institutionalizing research transparency. So thanks to our panelists.